Excellent. So if you all are here today and you're able to, can you give me a green check in the reactions so that I can just see who's here, who's ready to participate, how many people we have today? Good. I see some green checks. Excellent. I see a question in chat. Someone is asking, are the exercises today a continuation of the week 2 network diagram and code? It's like you knew what my next slide would be. Yes, so this is a continuation of last week's code. All 4 series build on each other. So if you weren't able to get last week's code working, that's fine. You can check out the temporary IDE code that I put in chat that has a full working version of what we did last week. For other folks, talking about where we've come from, where we're headed to. So in week 1, we looked at the command line. Week 2, we did the really heavy lift of getting NetworkX and Matplotlib working. People opened Sublime for the first time. That was the real hurdle of the workshop series. Now we sort of taper back off to give you all the knowledge that you'll need for one more really important library. That's pandas. You're likely to use that pretty much whatever you do in Python after this. And we'll have one more library that we'll do in week 4 to sort of wrap things up. But this week, what we're doing is taking what we hard coded last week. You know, we were putting in the various relationships of the Disney characters. It was a little whimsical. And now what we're going to do is instead of hard coding it, that would take forever. If you all wanted to do something like, let's say you watch Game of Thrones and you were like, I want a network diagram for Game of Thrones. You did it in that format, it would take you forever. And you're far more likely in your research to use things like CSV files. It's a version of an Excel file. So that's what we'll be doing today. We'll be connecting our network diagrams to a CSV file. For the purposes of the workshop today, I've provided those files just so that we can all be looking at the same screen, have the same outputs, and help each other troubleshoot. But the idea would be as soon as you have your CSV files hooked up, you can go forth and do whatever network diagram interests you, but that way you'll be entering data into the CSV much more fluidly, and dealing with CSV files using pandas, which is the library we'll be using, is something you'll have to get used to for your Python projects anyway. So no better time than today. I see another question in chat. Can I use Colab for today's class? That is another online IDE. Yes, you may use any IDE that you like. The reason that I use Sublime is it requires a lot more steps to learn, which I know sounds unpleasant as a beginner, but it allows you to touch things like the command line and start to get familiar with them. So if you end up running into errors later, maybe you have an employer who wants you to use something more hands-off like Sublime, you'll at least have heard of these issues, whereas sometimes something like an IDE like Visual Studio sort of covers things up more. But you are welcome to use any IDE that you like. So again, this week, what we're doing is modifying the code from last week to start connecting to some CSV files. That brings us to the next slide, which is talking about the CSV files we'll be using today. I will reshare this link in chat. It is a Google Drive that contains 2 CSV files. If you will please download those and put them in the same folder or location where your code for the workshop is. Hopefully that won't take too long. I'll go over what's in the concepts, what's in them, but the basic concepts are last week we made a nodes list. That was all of the characters. And we made an edges list, which was all of the relationships. This is a CSV file, one for each of those. One has the nodes in it, one has the edges. And the idea today is if you can get that hooked up and connected to your network diagram, not only will you have practice connecting to CSVs, which again is like 90% of the Python projects you'll do, but from here on out, if you would like to modify the nodes and edges that we're doing, I highly encourage you to find a subject matter that's really interesting to you. It could be as lighthearted as if you want to make a network diagram for your friends and family, or if you want to do something whimsical but very detailed. Again, if you watch a TV show like Game of Thrones, and you want to do a network diagram for that. A lot of people also have data sets for this online. So you're welcome after the workshop to start Googling like network diagram or node list for, again, popular TV shows, maybe a subject matter you're interested in. But for now, if you can download those two CSV files, I'll do a quick introduction to them, especially in case anyone is not able to see those today. I have everything on my desktop. Another good troubleshooting comment for today is you will want to have your node and edge CSV files in the same folder where you have your code. So if you want to take a housekeeping moment and organize yourself, make sure they're in the same location. The first thing I have open is the edges CSV. This is mimicking the code we did last week. I will pull that up so that we can look at them side by side. So this is a version of the code we did last week. If yours looks a little different, that's natural. It should have your own comments. It might be a little less complete. Didn't get as far as we might have liked last workshop. All of that is fine as long as your code was running and not breaking. We'll get you to a good place today where you're connected to the CSV files and running. So on the right, I'm looking at the code that we had last week. And this edges list, again, edges in the network diagram are the paths that connect the dots. This edges list is what's reproduced in the CSV file on the left. We have two columns. This is the header for each of them. Character 1, it's the first character, and character 2, that's the second. So you can see in row 2, we have Cinderella and Lady Tremaine, and that is the exact same thing in the code that I'm highlighting here. So that's what the edges CSV file looks like. If and when you want to make your own network diagram, this is where you would enter relationships between various people. So again, if you wanted to make one for your family or friends, this is where you would start to enter like mom is my parent and my mom is married to my dad. This is where you would enter the relationships. Okay, so I'm going to close that one. Take a moment and open the nodes.csv. This one is even more self-explanatory. I'm going to pull it back up next to the code. Again, the node list that we were working with last week was the list of characters. And you'll see on the left, again, we have a header, the word character, and then we have a list of all of the characters here. So what we're going to be doing this week is taking this code where we hard-coded the node list and we hard-coded the edge list, and we are going to replace that so that our code is now pulling from the CSV files. The beauty of this being you can then go in and edit the CSV files, which are a little bit more familiar. You can get a lot more in depth. It's a lot easier to have something like 100 or 200 characters in there if you get really into it. And then every time you rerun your code, it will run from those CSV files. The bonus being that we also learn how to use pandas, which is one of the most common libraries for connecting to CSV files. So this is the moment where we're going to pause and talk about what it means to use a new library. I know thus far in the workshop, it's been a big whirlwind. We've sort of, when we did the network X and matplotlib libraries, we were moving really fast. I was giving you the code. We weren't doing a lot of sort of exploratory, how would I start using a new library? And that's sort of the nature of the workshop because we only have 4 hours in total to learn Python. We have to go very quickly at the beginning so that everyone can have something running that we can then talk about. But I want to take this moment to describe how you would start to use a new library such as pandas. You would probably have the experience where you want to use a CSV file or have data in your project. You would Google, how do I do that? Pandas would come up as the #1 library. And then you need to figure out how to use it. So I'm going to talk about what that looks like. I'm going to Google, I'm pretending that I've heard about pandas, but I don't really know what I want to do with it. A lot of coding tools you might have had exposure to before, like MATLAB, or maybe you've used Excel. They have a lot of inbuilt help. But the thing with a coding language like Python or JavaScript or R is that a lot of the content people have developed for it is on the internet. And so it becomes a new habit I want you to get into. If you know that you're going to start to use a new function library like pandas, go ahead and Google it. And the thing you want to Google is the name of the library, in this case, pandas. You want to Google the coding language, in this case, Python, and you can see I've searched for this a time or two. You want to search documentation. So the documentation for a library, it's going to be the first result here. I'll be sure to share the link in chat, but we're just doing this as an exercise. Documentation is essentially a mini Wikipedia for whatever library of functions you're using. So in this case, let's pretend I've never seen pandas before. Perhaps for many of you, you haven't. I would click into the documentation. Every page looks different, but the library usually has a home page with some sort of link, such as getting started, to guide you through the process. And it usually has a search function if you already are sort of knee deep in it and want to look for something. In this case, because I know I want to install pandas, I'm going to click the getting started and watch where it takes me. You can see here, it's describing that I need to install it. It gives me options for Anaconda, which we've mentioned in passing, is a program that some people use to manage software like Python on their computer to do data science projects. We also recognize pip, our dear friend pip here. It's giving us a reminder that this is how we would install it with pip. And then it also has instructions for in-depth walkthrough to install the library. So what we're going to do is we're using pip in our case. So hopefully you all, I know, have had a bumpy road, maybe getting pip to work over the past few days, but hopefully you've figured out what your particular computer needs. If you have to specify that it's pip 3, if you have to be in a certain folder. But what I want you to do is follow these instructions that you're seeing in the documentation and use pip install pandas or a variety that you've discovered works for you on your computer, and go ahead and install pip, if you will. I'm going to clear reactions. If you can give me a green check if and when that works for you, that would be lovely. It might take a little bit of time. Oh, good. I'm seeing a lot of green checks. Thank you all for hanging in there. Again, I realize that using pip and getting libraries set up on your computer has been pretty big and a nightmare for many of you using Windows 10. So thank you for hanging in there. Hopefully that worked for you. If it didn't, I recommend Googling your particular error after class or sharing it in chat or the Teams channel. But another option available to you is somewhere here in this Pandas installation page will be information about how to install it, troubleshoot, and it's great practice to get into the habit of looking through documentation. It can be kind of intimidating because it's very long, but often they've made it very friendly so that you can find what you're looking for. For example, when I gave you this segment of code that we worked on during last week with the nx.graph, adding nodes, adding edges, we skipped over the step of reading Network X's documentation. But if we'd taken the time to do that, they have a page that they direct you to, just like Pandas with getting started, called the tutorial. And they walk you through everything from importing Network X to doing that G equals NX graph call. They tell you how to add nodes. They tell you how to add edges, and then they go further to tell you more about how you might examine different elements, how you get matplotlib set up. So I want you to think of this as you start to imagine projects that you might do on your own. Again, the way to look for any library that you know you might want to use is to put its name in, Python, and then documentation. It is almost always the first link. And when you click into it again, it will have something like install or tutorial as a place to start, but you could also search for various things, such as we had used the add nodes from function. I can copy paste that, search in the documents, and you'll notice it's leading me to a suggested page that's network X. It uses a graph, add nodes from. I could click into this and see actual examples of what people have done. So the documentation is a good place to start when we know that we might be coding with something. So for example, in the pandas documentation, we know we want to upload those CSVs into our code file so that we can start using them instead of what we hard coded there. There is a page within the pandas documentation that I went ahead and found for us, again, just for the purposes of time. But if you had searched in the documents for reading from a CSV or CSV file, you would get to it yourselves. You'll see in this section that we have a little bit of information, including example code. So what we want to be doing is we want to read from a CSV file. The documentation is giving us a link to an in-depth article, but we don't necessarily have to read that unless we need more help. What we can do is go straight to the code example here and see what is it that they're doing. It looks like they have a CSV file called foo.csv. Foo is a common joke in programming languages. It's the default. It's sort of like using the name Jane Smith when you come up with an example. It's just a funny word that people like to use in coding examples. So in our case, this would be edges or nodes.csv. We can see that they're using a read.csv function. And then we can imagine here that this PD is very similar to the way that we pulled in NX for network X. So what I want to do is I'm going to keep this documentation open in a window on the left. I realized as I resized, it scrolled. But here at the top of the page, I have the example code that we're looking at as we start to use pandas. Then in your file, just below wherever you have the node list and the edge list, I want you to start a new section where we start to use pandas. So in this case, I'm going to leave myself a comment that says pandas. You all are welcome to make that longer or put your own flair on it. Sometimes if I'm doing a project that's going to take a lot of time, maybe during the semester, I might step away from it for something like spring break. I will copy from the documentation wherever I was reading and put that in as an additional aid so that when I come back to the project, I'll know what I was working on. The beautiful thing about documentations is most of them have the ability, right here, I'm in the CSV section. If I press the paragraph symbol, the link up top here will go specifically to that section when I copy paste from it. So it's a little bit like bookmarking a specific word on a page. And when I paste that link in, I can get as specific as if I was reading about the CSV right here. I go away for spring break, I come back, I look at that link and it'll pick me up right where I was in the documentation. So that's a way to get around the fact that these documentation websites are incredibly dense, but it also means when you've found what you're looking for, it's a great idea to bookmark it, maybe include it in your code, and that way you can always reference it for help later. So enough about comments. What we want to do is import the pandas library. And we can see from that example on the left, again, I'm going to move my window just so it's at the top of the screen on the left. We can see that they're importing that library as PD. I will resize so that those windows are not in conflict. So similar to the way that we did with NetworkX, we are going to import pandas with the alias PD. Now you can tell from the pandas documentation that that's the common alias. You're welcome to create aliases of your own as you go, but just keep in mind if you're Googling errors or looking for examples that oftentimes there are common aliases. So when you see PD, you can start to recognize it as, oh, I know what that actually means. That means that they're using pandas. Sometimes Sublime will try and autocomplete. If it does, go ahead and delete it and re-enter your text and click out of that window. Sublime, again, giving us some challenges while it's also trying to be helpful. So I'm going to press enter just so that I have some breathing room here. I'm going to scroll up, but hopefully we're well located in our files. So the first thing we want to do is we're going to pull in that node CSV. So the way that we are going to do this is we're going to create a variable name. Again, this could be anything, but for our own benefit, we're going to name it something sensible. So in this case, node CSV. And we are going to set that equal to basically the code example that we're seeing on the left. So that PD dot read underscore CSV. And in this case, instead of foo CSV, we want nodes.csv. Now at this point, we could run our code and see if it breaks or not, but we're going to do a little bit of housekeeping here. Right now, if we run our code, every time we run it, that plot is going to generate and it's going to take time. So I want you all to practice what we learned last week. Find your plot.show line, which is the one that makes the window with your network diagram pop up, and comment it out for right now. Again, that's putting a hash sign in front of it. And what that does is suppress that line, turn it off. So right now there's no output. And we're going to add an output of our own so that we can see what's going on and what we're doing. Right below where you have that node CSV line, I want you to print that node CSV so that we can see what's happening, what's coming in, is it working correctly? And then if you will go ahead and run your code, again, that's tools, build. I'm going to be using the shortcut Command B, but I will say out loud when I am building. Please speak up if at any point that becomes confusing. If you build, hopefully you will then get an output that looks something like this. I'm going to take a moment and clear all the reactions. If you can give me a green check if that's working for you, a red X if not, maybe some comments in chat. If you're getting errors, are things exploding? See one green check. That's a good start. Thumbs up. Okay. If people are lost, please take an opportunity to either give me a red check or put something in chat. Otherwise, I will hope things are going well, but please don't hesitate to let me know. So what have we done just now? Thank you guys. I appreciate the green checks. I know you're busy coding as well. So what we've done is import that nodes.csv file and gotten node.csv to print out in the bottom so that we can see what it looks like and how it's looking in our code. This is great news. If your screen looks like mine, you'll see a replica of what was in the CSV file. That's very exciting. And now we want to know, how do we manipulate it? So I'm just scrolling up. You don't need to. But if you look at last week, we had this thing called node list. And now we want to know, is what we're pulling in from pandas the same as that node list? So here's where types in Python becomes a subject. So we just learned that documentation is one of the best places to look when you're learning a new library. For anything else, anything at all you need to know about Python, I highly recommend this website called W3 Schools. You don't need to worry about writing it down. It's in every slide at the end of the deck that I've sent. It will be in the slides for next week. If you Google on your own and completely forget the name, it'll usually come up as a recommended source anyway. W3 Schools is a site that teaches coding languages with little inbuilt explanations and code practice. So for example, I'm looking at their page for Python data types. I'm going to make it a little bit bigger so that we can see more. It gives you an overview of all the different data types. For example, when we were printing our names and the word hello in the beginning, we were using strings. Right now, we're actually using lists and something called tuples that we'll cover. If you had numbers, it might be an integer or a float. But this is a complete overview of the different data types that are inbuilt to Python. And just below it, W3 Schools tells you how to find out what the type of something is. They've included a helpful example. This is them creating a variable X, setting it equal to 5. And you'll notice they're using print again to get more information about what's going on. To get the type, using the function type X. And if I were to click try it yourself, it gives me this coding screen where I can change things. So for example, I could set X equal to hello and run it. It takes a while to run. So for the purpose of the workshop, we won't be doing a lot here, but I want you to keep W3 Schools in mind as a resource. If you don't have colleagues or I'm not around to answer a question, this is one of the best possible places to look. In this case, we're going to use this type function that we've learned from W3 Schools. So I'm going to resize this window again. Hopefully no one's getting dizzy so that we can see it side by side with our code. And what I'm going to do in this case is I want everyone to find the type of that node list we were using. So you want to put print, which is what gets things to print out at the bottom of our screen. And then we're going to use type. And inside that, we're going to put node list. Now you may want to go ahead and suppress your other print message by putting a hash on it. If not, it's okay. You can also leave it in there, but they'll start to build up over time. You can keep them in your code, but turn them off by commenting them out. Now when I run, I'll get a return that says that this node list is of type list. So what we're learning here is that what we created, which was this structure that had square braces and different items separated by commas, is a list in Python. Now I want you all to see what type is node.csv. So we're going to do something very similar. I'm going to say print. I'm going to use that type function again, and I'm going to say node CSV. You may again wish to turn off your other print statements so that you can be positive what line is coming out. Now, if I run, I see that the class is pandas.core.frame.dataframe, not something that I immediately recognize. What this tells me is network X needed a list. That's what we were using for nodes. Pandas is bringing in a data frame. I need to get from one type of data to another. Now, usually there is a section in the documentation for pandas that will tell you how to do this, but I'm also going to work with you right now to talk about how you might sort of improv and figure this out on your own, because it's likely the type of scenario that you might run into as you're working with weird data structures. Maybe you pull in a library that someone from your lab has made. It's got a lot of custom things. Learning how to print and type is a great way to go back and forth and kind of explore what's going on. So I am going to do a series of things now. The first one is I'm going to turn off this type statement. I don't need it, but I want to remember what it was in case I want to reference it later. And I'm going to reprint node CSV. You lose nothing except a couple of milliseconds by choosing to print something. So I'm going to run it, print it back here, and look at what this is actually bringing in. when node CSV is bringing in this content, it's giving me the row number along the side. It's giving me the header. But what I really want for the list is just the content inside here. So a common structure in almost every coding language when you have a data frame is that you can access data based on the name of the column header. So what I want you to try is just leap of faith. After node CSV, which is our quote unquote data frame type, I want you to put a square brace and then that character header. So what we're doing is accessing that column, and I want you to see what happens when you do that. When I did that, you'll notice that the header disappeared from my output. That's a good thing because I'm trying to get just to the content inside it. With almost any data structure, in almost any coding language, this object, such as node CSV, with square braces and the name of a header, is almost universally a way to access data. The next universal is there's usually something that gets rid of the row and gets to the meat of the data itself. That is called dot values. Again, there's usually some version of this in any library, in any programming language. I'm going to run that again. And this time you'll notice we get the values and it looks almost like a list, except we're missing one thing. There is no comma separating each of these entries. Now you would be able to Google and figure out what this is and how you get those commas, but to save time in the context of this workshop, I'm going to go ahead and give you the last piece here. The last piece is after that dot values, you want to use the function toList. Now, if I print, I will get a list that looks exactly the same, except there aren't line breaks, as that node list I had above. I'm going to scroll down so that folks can take a moment to catch up. I see there's a question in chat. Let me address that. Do you always need a header in your CSV file? What would happen if you don't have it? Excellent question. No, you do not always need a header. If you don't bring in a header though, pandas needs to be told that. So there is a setting. I'm going to pull up the header right now. I mean, the pandas documentation. Let me see if I search header really quickly, if it will say. That didn't immediately bring it up. Let's look at read.csv. Within read.csv, we're going to search for header as an option. Header comes up. What it tells you here, it's a long paragraph, so I'll go ahead and give you the short of it, is it assumes by default that there's a setting header equals true. You could add this option, header equals none, and it would look something like this in the code. Here's my read.csv, and I believe it would look like that. There might be a slight variance, but that's the basic concept. And what you would do is you would also Google to see if you could get an example, or read this page a little bit further to see if there was an example. So that's a quick answer to that. A reminder of where we are. We have just gotten node.csv. We've pulled it in. It wasn't the right data structure, but now we have made it the correct data structure by using this series of functions. We played with it inside the print function so that we could see it. Now we want to save this as a variable. So what you do is copy just that inside. Let's specify a new variable. In this case, we're going to be replacing node list, but let's make it a new name. So in this case, node CSV list, almost the same name, but a slight variance so that we can always have our static version, but move on to the more complicated CSV version and replace it. So I want you to take this new variable node CSV list and replace the node list in your network X code. And if you have that, if you can give me a green check or red X, I just want to check in at this point of time. Drop a comment in chat if things are going poorly or you have a question. See a couple green checks. I'm going to wait for a couple more just to make sure things are going well. Okay, thumbs up. Excellent. All right, so a reminder that this idea of feeling free to put whatever you want into your print statement, you could try all sorts of things. You're not ever going to break your code in a permanent way by printing something. Also, if you know your working style and you want to start doing something where you have print node CSV, I'm just going to show you all this. You do not need to copy it. And then you want to have the next part where it has character. Maybe you want to see what happens if I print character lowercase. You can put as many print statements as you want. And the worst thing that will happen is I run it, I get an error here, and I can see, all right, Python has a problem if I don't capitalize character. I learned that, I can delete it, and I haven't lost any time, really. There's no downside to printing. So whenever you're trying to debug your code on your own, just don't hesitate to print everything. That's 90% of how you solve problems in Python, and you shouldn't be afraid of printing any kind of experiment you want to do. The worst thing that can happen is you get an error and you move on. So hopefully that has now connected your node. Now we want to connect the edge list. So what I want you to do is use that same concept. We need to figure out what type is the edge list that we made last time. So if I go to print and I use type and I put in edge list, when I print it, I will get list, but you will notice that it's not just a list. There's something else inside it. You should be able to do that same concept where in node CSV, we used square brackets to access something inside it. Try edge list with a 1 inside it. We don't really have headers here, but we do have positions. If I print that, I'll show you what it is just to be sure. I can add edge list 1 at the top. This is printing this entry, Lady Tremaine and Drizella Tremaine, and it is showing us that it is a tuple. So there's a lot going on here. First of all, Python starts indexing at 0. It's really strange. I'm going to go ahead and change these to 0 just to show you. 0 is actually the first entry in this list. This is just one of those quirks. Some coding languages are normal and you start counting at 1. This would be the first entry. Some coding languages like Python are quirky and they start at 0. It's one of those computer science quirks to get used to, something to keep in mind. If you accidentally grab the wrong entry as you're trying to get different pieces outside of your data, try remembering that it could be 0 or 1. So what you think is the second position might be 1 back from where you're going. But what we're seeing here is that this little piece, this rounded parentheses sort of pair, is called a tuple. And the overall thing is a list of tuples. So even without knowing more about what a tuple is, we can identify that that's what we need. So coming down into our code here where we've loaded pandas, now we want to get the edge list coming in, and we know we need to get it from whatever it comes in into a list of tuples. Now, this would be one of those points where you could Google if you needed a little bit more support here, but we'll work through it together. In this case, we're going to follow the same sort of thing we did in node CSV. We'll make a new variable, edge CSV. set it equal to that pandas call, read CSV. And in this case, we're going to have edges.csv is our file. And we're going to do the same thing we did last time. We will print edges CSV so that we can see what is inside it. And taking a moment, we'll see we have other print statements right now. You can take a moment to turn those off or leave them as your working style allows. Then if we run it, we'll see a duplication of what was in that CSV file. This time we have two columns. We have character 1 and character 2. We recognize that we have those rows, and then we have all of the data inside it. So this is the tricky part. We need to get all of that data out, get rid of our rows, get rid of our headers, and take it from this data frame to a list of tuples. So the way we're going to do this is we're learning the next most important structure of general Python code. Again, today we learned about types. I recommended that if you want to learn more about types, you check out the W3 Schools article on it. This will come up as you do your own projects if you want to expand data types. Similarly, the next most important general structure you'll use in Python is something called for loops. This is a common structure in code if you want to iterate through something and do a bunch of different things. For example, let's say I had a list of names, and for each name, I wanted to do a particular action, like print out hello for that name. I need a way to do that and to tell the computer that I'd like to sort of iterate through something. So for more information on Python for loops, you can read through the examples here. They also have try it yourself examples. So here they have one where they have a list of different fruits, and they say for X in fruits, print that thing. So what's happening here is this is a variable. It could be anything you want, but in this case, they're using X, and they're saying go through this list, fruits up here, and for each item in it, take that item and print it out. So what we get in the console is apple, banana, cherry. Now this is a whimsical example where we're printing something out. It's not really changing data structure. It's not shattering lives. But the way that we're going to use it is we are going to iterate through the various rows in this data frame and spit out. We're going to take Cinderella and Lady Tremaine. We're going to make it a tuple like it is up here, and then we're going to put it together in a list. So the way we do this is we start out for is how we start a for loop. You'll notice as I type that word, it turns pink as though it's important to Python. That's because this is a recognized function the same way that import or as is. If for some reason your for does not turn pink, you'll know that there's something wrong, maybe a typo. In this case, we will be looking at a row, and we will be looking at a row in our edge CSV dot values. Now, the reason that we use not just edge CSV, but we use dot values is we only want this content inside of our data frame. We don't want the headers. So what this is going to do is iterate through each row and grab only the content inside it. So it's doing something incredibly similar to what we saw up here, where we were taking the character column, changing it to just the values, and putting it into a list. So in this case, the way you end a for statement's beginning is you put a semicolon here, and you'll notice when you press enter that the line is automatically indented. Anything indented is now inside this for loop. So I want you to try printing the row inside this for loop. Go ahead and turn off any other messages you have and try running that and see what happens. In this case, what it did was iterate through that file, and for each row, it's printing them out. We only have one print statement here, just line 40, but we can see it repeated for each row in the code. That's an excellent sign. That tells us our for loop is working. It's iterating through each row and printing it out. So the first thing we know we need to do is this is not the right data structure. We see square brackets and no comma, whereas we know what we need are rounded brackets and a comma called a tuple. So the next thing you'll learn is that you can force a data type in Python. The way to do this is take your row variable and use a function that says tuple around it. What we're telling Python is take our row and make it a tuple. Now I want you to try printing it out and watch how the square braces go away and you get that rounded braces and comma that we expect from a tuple. What we've done is forced the data format here. This is described in detail in that W3 Schools data type section. You can read more about that here, but the basic concept here is this is called forcing or casting a data type, and it allows us to switch between different data structures. So now we have our tuples, and what we need to do is put them into a list. The way we do that is we create an empty list so that each time we go through a row, we make that row into a tuple, and then it's sort of like we put it in our basket. We put it into the list. So the way to do that is first start by creating an empty list. In this case, we'll call it edge CSV list. That mirrors what we called the node CSV list and gives us a similar structure. And I want you to make square braces with nothing inside it. This is our empty basket. The next thing we want to do is take that empty basket and add to it as we iterate through our data. So if you'll create a new line inside your for statement, again, you'll know you're inside it if it's indented. If for some reason your cursor is over on the left, you can indent yourself using the tab key. And what you can do next is we want to add something to the list. The way you do that in Python is you take the name of the list, in this case, edgecsv.list, and we use a function called append. So what this does is anything you put inside this function will be appended onto that list. It will be added. So we want to take our tuple row, that's where we're forcing the data to become a tuple, and add it in there. So what we're saying is for each row in our edges CSV, look at just the data, then take our CSV list, which is empty to start with, and append to it our row, but make that row a tuple first. If you will then print for yourself edge CSV list, you will hopefully see that it is a complete list with tuples inside it. So I know this is a lot to wrap our heads around, but this is the basic concept for sort of getting started with a for statement. We're iterating through our data. If you were doing it on your own, you would do as many print statements as possible throughout the process, figuring out what's going on, what does it look like, how can I change it? The last step here will be to take that new variable we've made, that edge CSV list, comment out any print statements you have so that they're turned off for now. Go to where we have our add edges from, replace that static list with our CSV. And the last step is to uncomment our plot show line so that now when we run our code, we should get a network diagram. So I'm going to clear people's reactions, get a clean slate going here. If you can give me a green check if that went well, or a red X, I'm going to answer some questions while people catch up. I will also move this network diagram so that it is not on top of the code that everyone is going to look at. Let's see, question. How does pandas recognize character 1 and character 2 as a header, but not a part of the values? This is an excellent question. Let me pull up that CSV file. Let me know, someone put in chat if you need me to come back to the code. I don't want to rush away from it, but I do want to talk about whatever questions people have. Sort of the question being asked, if I understand it correctly, is here in the CSV file, you'll notice character 1 and character 2, there's nothing about them that makes them look like headers. I mean, usually if you had a CSV file, a data file, someone would at least have bolded them, they'd have put some formatting. How does pandas recognize those as headers? The answer is that by default, pandas assumes that you have headers and that it is always the first row. So it's not particularly clever. You could make these absolutely anything. These could be complete gobbledygook and pandas wouldn't care. It would assume as long as they're different, there's no problem. And it would assume those are headers. They mean something to you. And as far as how does pandas know what to access, let me reprint Edge CSV so that we can look at it together. I'm going to turn off my plot so that it doesn't appear. When you use that dot values function, that's right here, that automatically strips out both the headers and the numbers on the side. That's simply what pandas does. So you can be guaranteed that it will take out those headers and those rows, which it has essentially put in itself. Okay, another question here. Could you append in rows instead of a single row? Juan, can you clarify that a little bit for me? I think I'm not fully understanding your question, and it has nothing to do with you. It's just been a long day. Can you expand on that just a little bit? I'll wait for you to do that, and while we're doing that, I am going to wrap up with a few final slides here. Homework, quotation marks, homework, as always, is just to catch up with wherever we are in the workshop. If you installed pandas and it worked well today, wonderful. This is like the most important library you will use. So if you got it working today, that's wonderful news. It will serve you for the rest of your Python career. The other part is to make the diagram that we made today. If you need a reference, I have the working code in a temporary IDE link. This will be sent out with the slides. I highly encourage you to take those CSV files and make them more interesting. I think we can all have a good laugh about the fact that this tiny network diagram does not really do justice to the power of network diagrams. I really hope that you'll take some characters and some relationships that interest you and really play with this to the fullest. Test out the CSV files, make mistakes and errors if you can. It's a great way to get familiar with pandas. You can ask those questions either in emails to me or in Teams. The last piece here again being how can you get help? I have some links from today's topic, but I want to pull you back to this column on the right, which most people have probably ignored this whole time. You've essentially been drinking from a fire hose while learning this, so I'm not surprised. But I want to reiterate, here is the link to W3 Schools. Anything you want to learn in Python, anything you feel I haven't covered very well, if it's not a specific library, if it's a general Python concept, will be covered here and will be covered extremely thoroughly with working examples you can play with. If you're looking for more general tutorials, maybe you've started to have an idea of what project you might like to work on next, Real Python is a fantastic place to go. They're very thorough. It's the sort of thing you could do self-study on. I think many of you, while running into errors during installation, have already come across Stack Overflow, but I will really quickly say anything you want to do in Python, Stack Overflow is a forum where wonderful people post questions and responses, but what you may not know is that you can add a brace, a sort of square bracketed word Python to the beginning of your search, and that will narrow down to just things related to Python. So if I was going to say pandas header not working or something, of course, that is not going to work for me. The one thing I type in, guys, but this is where you can search for installation errors. I think this might be my internet as well. Sorry, folks. But the basic concept being you can use Stack Overflow when your internet is working. And the last link here is my email address and links to appointments with me. You can book consults. Hopefully you won't need them, but if you are interested. And the last screen that I will come up with is if you have not joined the Teams channel yet, here's the information to join the Teams channel. I will be wrapping up a little bit earlier today, 3 minutes left. I want to thank you all for your time. I know that this has been, again, drinking from a fire hose. The last week we will be making this network diagram interactive. We'll be using one more library, and it's going to make it something that you can move around on the screen, you can click with, interact with. It'll be the sort of final piece, and we will hopefully cover the last bit of what you would need to do a project on your own. If you run into an error in the meantime, please reach out to your colleagues or to me. I will stay around for a little bit, answer questions in chat, but otherwise, please enjoy the rest of your evening. All right, Juan, you're asking, we get a list in a single row. Your question is if we could get that final list appear with each tuple in a row, similar as it is structured. Okay, Juan, I'm going to catch up with you. Again, it's been a long day. I apologize. It's not the phrasing of your question. It's all me. Oh, are you saying that you'd like to see that tuple list look more like edge list, like nicely formatted, where like this looks like a tuple in the output? I don't know if you can see my highlighting. So we have one row with 7 tuples. Can we have 7 rows with 1 tuple each? Yes. Let me think about that for a minute. So we have one row with 7 tuples. That's what we get when we, hang on. Yeah, like having a column list. I think I'm understanding you, not as well as you would probably like, but let me print out. So right now it looks like we have one row here with 7 tuples in it. Could you have 7 rows with 1 tuple each? Could you? Yes. Do you want that? I don't know. If it's just from a formatting standpoint of like you'd rather look at it nicely formatted like edge list where there's a line break. I'm sure there is a way to view lists with a nice line break. If we're talking about actually a different data structure where we have 7 rows, so it would be like 7 square bracket pieces with a tuple in each, we could have it, but it won't be the format that Network X wants to read, if that makes sense. But you can make any data structure you can imagine, you know, for better or for worse. Does that help? I know that was probably not the clearest answer, but hopefully that did something. Anyone else who's on? Or you're thinking in a matrix? Are there different functions to append rows than columns? Oh, I see what you're saying. Okay, I'll be perfectly honest with you. Pandas definitely has distinctions between rows and columns. No, you're being perfectly clear. This is, again, long day for me, not you. Most coding languages in general, when you bring in a data table that has rows and columns, which if you're bringing in any meaningful data, it's going to have at least one row and at least one column. While I'm talking, I will pull up the link to join Teams because someone is asking for it. But yeah, when you pull in a data frame in any coding language, there will be functions to make or manipulate rows and columns. They are usually different. I see what you're saying about having a matrix. I believe there is a way to do it. I would look in the pandas documentation though, because I am not going to remember when I try and pull that up in my mind, the functions in R are coming up. And that's not useful, but yes, most people, when they pull in pandas data, are not trying to get it into a network diagram. So they will actually keep it in the pandas data frame structure. They won't be doing all of this tuple and row and all that. And they will be using things like functions to access rows and functions to access columns. Those sort of functions are the type of thing you might use if you want to say, take the maximum of a particular column of your data, or filter out all rows that have a particular value in a column. So yes, there are functions, but I'm failing you today in giving you the actual answer. I recommend looking in the pandas documentation, search for just that in Google, how to handle a matrix or rows and columns in Python pandas. You can also send me an email if you would like a better answer tomorrow. Great. Anyone else? I see we still have 8 people here. I just want to make sure everyone's getting their questions answered if they need them. I'll let a little bit of time pass, but then otherwise I'm going to assume anyone who's on here is just sort of floating. Maybe they've wandered off for dinner.